Ready? Okay, we are now live. Are you feeling better, Kaylee?
Yeah.
Good, glad to hear. All right, so I can read the first one, first question. Okay, let's see. Oh gosh, I regret this. Suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is it equals 0. The alternative of hypothesis is not equal to 0. And the population deviation is sigma is not known. Jordan collects a sample size 9 and computes D bar equals 2.2 and S the power of D equals 3.3. What is the value of the test statistic? All right, let's see.
I've been trying to open up, that's not working.
Which one?
I just can't get those data files open on my computer.
That's weird.
It's a blank page.
Oh, the 12 data A, 12 data B. I haven't tried opening them yet.
Go ahead until you guys are eat. It's okay. Wait for Preston. It's okay. We should wait. No, let me see how long this takes me. You guys go ahead if Preston.
Did you guys get 2?
I got 2.
Cool.
Are you doing it by hand or using the data?
I made an Excel sheet for it, but it's just like the same as like I have an Excel sheet to do it with. Just putting the equations in Excel. Did any of you guys do it by hand, or how did you do it?
I did by hand.
I just use an Excel sheet.
Yeah.
Don't wait for me. If you want to go on, that's okay. I just gotta get these downloaded and figure out why they're not opening.
What's the data spreadsheets aren't opening?
Yeah, I think it was saying that it was a blank sheet, but now I've tried to save it and reopen it, and now it's open.
Yeah, mine's running like super slow right now. What's the... Never mind. Are you guys doing number 4?
Not yet. No.
Oh yeah, we're just waiting.
Okay.
Let's just move on because I can't get it to open.
Okay, we can always help you. I mean, you don't have to have the spreadsheet. That's okay. I know it's better to practice. But... Someone read the next one.
I'll read the next one. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. What are the degrees of freedom?
8.
How did
Wait,
you...
no. The degree of freedom is just n minus 1.
Okay. Okay, so did you guys get 0.96 or 968?
No.
Sorry, 0.968.
0.081.
What did that? Hold on. What'd you get?
I'm not sure how you're figuring it out.
I think I did it wrong.
How have you guys been figuring it out?
I think I did it wrong. I just took the test statistic and I put it in to the probability applet with 8 degrees of freedom and highlighted the area below and under the middle. But I don't think that was how I was supposed to do it.
Yeah. I'm trying to double check to make sure I'm doing this right. I don't know if I did it right, so I'm double checking mine too.
Oh, wait. Okay. Wait, so you got 0.0805? Is that what you said you got?
I got 0.08. Yeah, 05. I've just rounded to
Oh,
0.081.
okay. So I see what I did wrong. Yeah, you're right. I put in the probability of obtaining a test statistic greater than his. I used that number instead of the actual test statistic.
Oh, okay, that makes sense.
Okay, but what I don't get is why did they tell us the probability?
I know, that's what I didn't understand
'Cause it
either,
doesn't really
but I didn't
have
even use
anything to do
it. I don't know. So that's, I don't know if mine's right or not.
So 0.081.
Yeah, 0.081.
Maybe they just gave it to us to screw with us.
Yeah, maybe it'll be like, no, the next one's a different question. So
So how did you get it?
So you know the applet that they gave us?
Mhm.
We know that the test statistic is 2, and this test statistic 2 is the same as the, that's what
T-value.
t equals. So you put 2 in there, and you're looking for the numbers that don't equal, because that's the hypothesis that you're looking for. Or the alternative hypothesis is anything that doesn't equal this. So you don't highlight the middle, and you just highlight the 2 outside edges. And then the degrees of freedom,
But
like
doesn't
it
it
says,
say doesn't it say the probability of obtaining a test statistic greater than Jordan's test statistic of that? So wouldn't it only be one-sided if it's just greater than that one?
well, maybe that's why they gave it to us. It might be a good point.
Are you using the normal probability applet or the student's t probabilities?
The student's t probability.
Yeah, that's what
Okay,
I
so
used to.
if you only highlight anything greater than that, it gives you an area of 0.0403, which is exactly what.
Exactly the same. That's, yeah. I think you do
So
both
they're
the
just-
outside
yeah.
ones.
Yeah. Oh, so that's why they gave it to us. It's just telling us if you just highlight the greater, then you should
Then
get
it
0.
would, that makes sense now. Okay, I'm like, I don't know.
Okay. Yeah, so if you just unhighlight one of them, it'll give you half of it. Okay.
Did
So
everyone get that? We're good?
0.0806?
0.081.
Yes.
Okay, so this data, you do this.
I feel like this is half psychological class, half.
Seriously. You're like, am I doing this right? I don't know. All right. So this next one's where we use the data. Are you still there, Angie?
Yeah, I am. I'm still fighting with it. It's logged everything out, and I had to get back in the quiz. I don't
Oh,
know.
you poor thing.
I don't know what's going on with it. It's wigging out.
Okay. So the next question, I'll read it then again. Still trying to figure out her thing. So use this data file to answer the next 6 questions. Perform a paired sample t-test. Use the null hypothesis that it equals 0 and the alternative hypothesis that it does not equal 0 with a level of significance of 0.1.
So 0.407 is what I got.
I got 0.407. And what is the p-value?
Did you get that?
Oh wait, yeah. Sorry, I'll wait.
So figuring it out.
It was copied and pasted pretty fast, so that's why. So you'd want to use the one where you have the.
Are you using the Excel sheet that they gave us, or did you make your own?
I have a different one, like just has the equations in it, but then I also use the one that they gave us. That's the one I'm using right now.
Okay, because I just used the one they gave us.
Yeah, that's the one I used, yeah.
So what did you get?
0 or 0.407.
Okay.
Is that what you got? Okay, so then what is the p-value? The p-value is 0.689, right?
Yeah.
Sorry, my thing's freaking out now. Where did you go?
And since the p-value is greater significance, we fail to reject, right?
Yep.
Okay.
Failed to reject, yeah.
I'll read the next one.
689, right?
Okay, 8.
Suppose your alternative hypothesis is instead that it is greater than 0. What is the correct decision based on this evidence?
We don't have like really good
The p-value.
It would still be the same.
second one? Or no?
Well, okay, so the p-value is now still greater. So that means we'd still fail to reject.
Mm-hmm.
Have insufficient evidence. Yeah, so I think it's the second one.
Mm-hmm.
Okay. So, okay.
Are you with us, Angie? We don't want to leave you behind.
I'm just trying to do two things at once, but I think I'm keeping up. I'm still
Okay,
trying to figure it out.
okay, good. All right. Are we the next one? Okay, so so use the another file to answer the next 8 questions. Perform a paired samples test. Be sure that the test does group 1 minus group 2. This data comes from nosocomial infections. The null hypothesis is equals 0. The alternative hypothesis does not equal 0. And the significance of the level of significance is A equals 0.01, which is greater. Okay.
Okay. I got n is greater.
Yeah.
Yeah.
Okay, what is the p-value? 0.001.
Mm-hmm.
What decision do you make? Wait, what's the null?
Reject the null.
Okay, so we reject, yeah. Okay. So you decide to try another alternative hypothesis. This time you use that it's greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? Oh no, wait. I didn't have it not equal to before.
Doesn't, I don't think it changes it
The
for
only
those.
difference is still 0,
Okay,
0,
yeah,
1.
the answers are still, okay. So now it's greater than,
It would be 0, 0s, 3 zeros and a 6, which would be rounded up to 1 anyways.
Decreased.
So it, yeah, decreases.
yeah. Wait, so for number 10, that wouldn't be 0.001?
Yeah,
It is.
rounding it.
Oh, it is.
Some
Oh,
of the
that's
numbers
fine.
don't change if you don't change that area.
But it wasn't, since it's rounded, they're basically the same. Okay. Null, right?
Yes.
Reject the null?
Yeah. Okay. Based on your response from the previous question, what conclusion do you make?
Well, you know there is a mean difference.
So the
So is it the
third one,
third one?
We have sufficient, yeah.
Who wants to read the next question?
I'll read it. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
Oh. We don't have enough
Um,
information to
yeah.
do that, I feel like.
It got smaller as it got larger, and I'm assuming if it got smaller, it would give you the same result. Greater than or less than, I mean.
I think it's not enough info, but
Yeah, because you can't, it really depends on where it is on the thingy with greater than or less than.
yeah.
Okay, I am unsure of this question. I mean, I could trust you guys, but I don't understand why. For this equation, of course, the greater than is going to give you the smallest p-value. No, how
But if
that
the test
changes it.
statistic were negative, then it would be the opposite.
Oh, really?
Mm-hmm.
Okay.
Because it would be traversing the middle ground and then the upper for greater than, and then it would just be traversing the left side for less than.
Negative. Oh, you're right. I just checked it out just because I was curious. Okay, that's interesting.
Mhm.
All right. 16. Who wants to read that one?
I can read it. So we're going to determine the 95% confidence interval.
Okay.
So what is the point estimate for this 95% confidence interval? So 11.955.
Wouldn't it be
Using,
11.96? Oh yeah, 955.
are we using the greater than or the equal to?
Nah, I just put not equal to.
Or not equal to?
Yeah, that's what mine is at, but
Change it. Oh, it doesn't
I
even
think
change
we're
it.
going back to like the original or
Okay. Point estimate. Estimate the difference between the confidence interval. Is that? I don't remember what it was.
I think do we have to do the equation for this? Was that what it's?
Estimate.
I can't remember this one.
We could just do
So
I
minus
just don't remember.
minus it.
.652.
Can you guys remind me how you get point estimate?
It's just the mean. It's the main part. And you
The
add
difference
the
between
margin of error.
Sorry, it cut out a little
6.652.
bit. What'd you say?
So it's the mean, and then you add the margin of error, which gives you your confidence interval, but the mean is the point
Okay.
in the middle.
Wait, you're cutting out. Sorry. But I got 6.652.
Me too.
Okay. 6.652.
Did you understand that?
And
Why
figure
we got how we got that?
No. Oh. Use the difference for the means? Because there's
So if you do
there's
the
two different
confidence.
means.
Sorry, my calculator. You do the confidence interval, you minus them, and then divide that by 2, right? That's what I did, but
I just looked at the spreadsheet and took one of the confidence intervals. And
Okay,
so I
let me
took the
see if I can do
higher one and I minused the mean, and that gave me the margin of error.
When I take the confidence interval and I subtract the smaller one from the larger one, divide it by 2, it gives me 15.955.
So you do 18.607, the high one,
Yeah.
minus 5.303, and then you divide that by 2, it will come out to be 6.652.
Oh, I forgot to put parentheses around
Or
my
you
equation.
could,
That's why it's screwed up.
Or you could probably do
Figure
what?
it out.
or you could just take the higher confidence interval and just minus the mean from that. You'll
That's
get
cool. I didn't know that was a thing. Funny, it came out the same answer, so apparently it worked.
Okay, okay. I was just in the equation. I forgot to put parentheses around
Oh, gotcha.
things. So okay, so 6.652.
Yep.
Cool.
And these ones are pretty simple. But
Okay. There.
the lower bound, which would be 5.303. And
I
the
didn't know
higher,
that. Okay.
18.607.
Wait. For margin of error.
for
The
the
high, the upper, like the higher.
Wait. Okay. Were you on 18?
18
Or
is
did you get
bound.
The lower
18
bound.
is 5.303.
Yeah.
Wait, what was 17?
17 was a 6.652.
Wait, oh, then what's the point estimate? That's oh, okay. I was really confused. What's the point estimate?
Point estimate was the differences. So like the mean differences.
So it's just the mean.
So it's
So it's just-
11.955.
Okay. Sorry, I was totally off.
No, you're good.
Okay, so I thought we were on a number 16 when you guys were on 17. I was confused. Okay, so 16 is 11.955.
Mhm.
17 is 6.652.
Mhm.
18 is 5 point.
Yep.
And then the next one is 18.607.
Yep.
Okay. All right. Now I think I'm caught up. Awesome. Yay.
Yeah, I submitted it. We got 100, so that's cool. Anna, did you need us to repeat any of them or anything?
Wondering. I'm sorry. Go ahead.
Oh, go ahead. I'm gonna.
All right. I was just wondering. How come they use like different terms for different things? Like, why do they say point estimate when they mean the mean?
I
Although,
think
okay, I guess
in
point
the reading, it just talks about that in this section, this is what they call it, rather than being called what we like used to call it. They call it something else. But
I think it's just because of the different context of the situation.
yeah,
And I just think
Yeah.
statistic people like to complicate things over there.
yeah.
Actually, now that I'm thinking about it, I think point estimate would mean the difference between the two means.
No, that's
The point estimate is just the mean.
it's just the mean. Did you submit it?
No.
Oh, I already submitted it. We got 100. So
For because for point estimate, if you look at the equation, it's not the variable 1 mean or the variable 2 mean. I don't know.
Yeah, so
Hold on, I haven't
when
submitted it yet.
you're taking group 1 and you're minusing group 2, and that difference is the mean of that difference.
it already did it for you.
Okay.
Does that make sense to you?
Yeah.
Okay, good.